Okay, so last time we started off doing variation of parameters. So I was going to do some more examples of those here tonight. So this is like section 5.7. Okay, variation of parameters. Let's see. Okay, so before we start that, one thing to mention, there's a question about like the taking the second derivative. So I mentioned there was kind of a trick for taking the second derivative of a product. So it's like this here, not really a trick, but like more of a formula. But if you have u v double prime, okay, that's equal to this then. U double prime v plus 2u prime v prime plus u v double prime, like this. Okay, so this is the formula for taking second derivative of a product. So for example, so you have like sine or x squared sine x as an example. Okay, this is equal to what then? Well, you would take two derivatives of the u, that's this part here. So two derivatives of this would be 2, and then you keep the second part. Now this time then, you have 2 times, and I take the derivative of the first part, so it'd be 2x, and then the derivative of the second part here would be cosine x, plus, and for the last one here, now you keep this one, and multiply them by 2 derivatives of this one, which would be back to negative sine x. So this guy here then, like this, for an example here, this would be the second derivative here then. So the second derivative of this one would be this guy down here then. So, okay, so that's just a little bit how that second derivative rule works there if you have a product there. Okay, so then let me go back here then, and yeah, back to variation of parameters then. So let me bring this back down here, let's say. So copy, and then put this here. Let's see. I'm speaking to the phantom class right now, except there's somebody came in here now. So, okay. So anyway, you got one online. So, but anyway, variation of parameters here then. I was just going back over a few more examples of this here then. But just kind of recapping variation of parameters. So, okay. So you have a second order differential equation here. Okay, got this one here then. Okay, this is kind of what we were doing last time. Nothing really new here. Just kind of recapping the variation of parameters. So same thing I wrote before here. But basically, I have your second order differential equation here. And then what we got, this general solution here for this, it's y equals y sub c plus y sub p. This is general solution, okay, where right, y sub c is equal to c1 y sub 1 plus c2 y sub 2, where this is the general solution to the homogeneous equation. Homogeneous equation, that's where we have a 0 over here instead. Okay, and so we have that. And then now the yp here then, the y sub p, particular solution to the non-homogeneous, okay, you can write like this then, where these are functions to be determined here. Okay, this u sub 1, u sub 2, those are functions of x here then. Okay, so that's this part over here. Okay, where the y sub 1, y sub 2, that's the same parts here as in the general solutions of the homogeneous equation. These are called the fundamental solutions here to the homogeneous equation. That's the y sub 1, y sub 2 here. Okay, and then now for the u then, where u1 prime is equal to a little formula here for it. It's negative y sub 2 f of x over w. We have to define w next here then. And y sub 2 prime is equal to y sub 1 f of x over w, where, finally here then, w, it's equal to determinant here, y sub 1, y sub 2, and then the derivatives down here. Okay, so this is the whole thing here for variation of parameters. So basically solve the homogeneous equation to get this, that, then you can identify the y1, y2, and then you start back down here at this, and then work your way back up here then to get the particular solution. So you kind of work down to here, and then to get these two parts here, and then work up here then like that. So, all right. So any questions on that? Okay. All right. So, so let's look at another example like we did last time. So let's say we want to find a general solution here. Let's say we have, so y double prime plus 6y prime plus 9y equals e to the negative 3t. You want to find a general solution here. Okay, so basically it looks like this. Right, this would be the general solution. So we have y equals, now y sub c, that is the general solution to the homogeneous equation. Okay, so yeah, I'll start with this here. So basically then, I guess working the y sub c then. So I solved the homogeneous equation. You have your characteristic equation here, r squared plus 6r plus 9 equals 0. Okay, and then that's going to be, it's r plus 3 equals 0. So it's repeated here then, right? R equal negative 3, R equal negative 3. So then we have that y is equal to, the y sub c then is what? C1 e to the negative 3x plus, and then if it's repeated, if we remember here, anybody remember what to do here with this? Okay, you put an x here if it's repeated. Okay, so get this here then, and then so that's the y sub c here is that, and then plus y sub p. So we have to find. So this is our general solution here. We got to find the y sub p then. Okay, now for the y sub p, okay, basically then we start then with the Wronskian. We start with this one here with the w. This is called the Wronskian. Okay, so to work the problem here then, we have w equals, so we're looking for, again, working on the y sub p here now. So we have w equals, we have then what, e to the negative 3x, and then x e to negative 3x. That's the y sub 1, y sub 2. Make sure I have this, okay? And then take derivative here. So that'd be negative 3 e to the negative 3x. And then over here on this one, you have to actually use the product rule to take the derivative. Bit of a mess. Derivative first part would be 1. So you get 1 e to negative 3x plus now then you keep the second part, or you keep the first part, multiply by derivative of the second part. You get this then. I think like this you would get. Okay, so if I did that right, got to double check that in my head. I think that's right. So, okay, we'll go with it. So then now, what do you do? They multiply these together here, and then basically crisscross these, right? Multiply this way, subtract. So if you do that, I get like e to the negative 6x, right? Minus 3x e to the negative 6x. Right, exponent rules there. That's multiplying these together. And you have to kind of distribute through there. And then now minus, but let's go turn into a plus then, because I already have a minus here. Yeah, okay. And then that would be 3x e to the negative 6x, right? See at this? Okay. And then it's nice here, these actually cancel now, right? So this is equal to then e to the negative 6x, because that's the w then. Okay, so anything there so far? Okay. Now next up then, the u1 prime is equal to its negative y2, which is this, so negative x e to the negative 3x times f of x then, and the f of x is the e to the negative, well, okay, I should be using, I have t's and x's. I'm going to take the way out here and just call this an x. I mixed up my independent variables here. We'll do that there. And then, yeah, and then it's e to the, what, e to negative 3x. That's the f of x. Okay, over, then it's w there. So that's e to negative 6x. Okay, then u2 prime is equal to, what? That's y1, which is this one here. So that's e to the negative 3x. And then f of x is again, it's e to the negative 3x again. Over e to the negative 6x. Okay, so if we clean these up here, y1 prime is equal to, I think that's just negative x for that one. And then y2 prime is equal to 1. Yeah, it looks like 1. I guess you get 1 there. Okay, so anything else so far? So then u sub 1 is equal to negative 1/2 x squared. You do not need any plus c's here. So no plus c's on this. And then u sub 2 is equal to x then over here. Right, so a particular solution then would be the u sub 1 times the y sub 1, which was the e to the negative 3x, plus, and then u sub 2, which is x, times then the y sub 2, that'd be x e to the negative 3x, like that. Okay, so then if you clean this up, we get negative 1/2 x squared e to the negative 3x plus x squared e to the negative 3x. And actually have like terms here now in this. So you get like a 1/2 then, right? So you get 1/2. So y sub p is equal to 1/2 x squared e to the negative 3x. So then a general solution, what's y equals c sub 1 e to the negative 3x plus c sub 2 x e to the negative 3x plus, and then 1/2 x squared e to the negative 3x. Okay, so that would be it here then for that. Okay, so right, so that'd be the general solution there. Okay, so anything on that? And I'm just checking here. Let me check, make sure I got this right. That should be it there then. Sub 2. Yeah, okay. Okay, and the original backup here, it was this one here then, right? So we had that. Let's see. Okay, so yeah, so that would be out there. Now, the other way you could do this too would be the method of undetermined coefficients, right? So you could go through and do it like that. Okay. Let's see. But yeah, that'd be the other way to go about it then. So you shouldn't end up with the same thing in the end. So you should end up with this here for the answer. We did that. I think I made a mistake in my note looking at this. I kind of think flub this up here a little bit. Let's see. Yeah. All right. So anything on that one? Okay. Maybe on this one, I just want to check my particular solution. Oops. If I check the solution here, you don't have to do this usually, but I just want to see something here. Y double prime minus 6 y prime plus 9y equals, it was e to the negative 3x. Right? That was the original differential equation. Okay. Well, I don't know if I'll do that or not. If I go through and check it, it should work out if I went through this. So it might be a little bit to go through it. So I changed my mind on it. A little too much work there for that, but it should work out there. And so. All right. So let's see. Okay. Yeah. So. Okay. Next up here, let me try another example of this. Let's see. Okay. Let's try.
My cousin, 11-year-old Sunday.
Let's see. Try this one here now.
Forgot. Well, most of my pop.
Did I lose a negative sign somewhere? I did. Wait a minute. My bad. No, I didn't. Never mind. I put these together here. So that worked out okay. All right. That should be it there. I think I made a mistake in the note. That. Okay. Next up here then, let's try another one. Okay. Let's try this one here now. Let's say, yeah, so let's say we've got y double prime plus 12y prime plus 27y equals negative 12 e to the negative 7x. Okay, let's solve this one here then. We'll use variation of parameters here again for this one. Okay, so first thing here, we'll solve the homogeneous equation. Okay, so if I start with that, what that'd be like r squared plus 12r plus 27 equals 0. Okay, and typically if I'm nice, it'll factor nicely, so you don't have to get into quadratic formula and stuff too much with this here. So then that would be what, 3 and 9, right? So r plus 9, r plus 3. So r equal negative 9 or r equal negative 3. So then we've got y equals, that would be c1 e to the negative 9x plus c sub 2 e to the negative 3x plus the particular solution over here. Okay, now we can start working on getting this. So work on this part here now, variation of parameters for that. Okay, so first thing here, get the w. That's e to the negative 9x, e to the negative 3x. Take derivatives here. Okay, so you got this. And then find the determinant. So that would be what? Negative 3 e to the negative 12x. And then going the other way, I think it'd be like plus 9 now. Plus 9 e to the negative 12x. So it looks like 6 e to the negative 12x. Okay, so we have this here. Okay. And, oh, well, let me check something. Did I make another boo-boo here in my notes? Let's see. Let me check something here. That'd be, oh, I just put them in the other order. Okay. Okay. So we're okay here. So we got this here. Let's see now what. So now U1 prime, we can go right to this. It is negative y sub 2, which is this one, times f of x. And f of x is this one up here, negative 12 e to negative 7x. Okay, over the w. So we got that. So that's u sub 1 prime. And then we got u sub 2 prime is equal to e to the negative 9x. That's this one here, the y sub 1. And then times f of x.
Oh, I get it right. I'm a white
7x
boy, huh?
Yeah.
over,
I
and
have
then w
a
again,
Subway
6
gift card to go to
12x.
Subway.
Okay, anything there so far? Any questions?
How am I supposed to pay for it?
I got
Okay,
a card.
and then we got what? U sub 1 prime is equal to
I got money
I
on,
have $20. I have $20.
oh, be positive.
oh, we'll get you some.
And I think the 12 and 6 make a 2. And what? This is negative 10. And then subtract negative 12. I think it's e to the 2x.
We left it in there for too long,
Maybe.
but this is good.
Does that seem reasonable, Nat?
Oh, yeah, but I had negative 2x.
Oh, okay. Is that right? Okay, so e to the 2x. Okay, and then the other one over here, that would be negative 2, and then that would be negative 16, and then plus 12 be negative 4. So e to the negative 4x here. Okay, so you got that. Got this here. Okay, so then, yeah, now I'll do antiderivatives. These are not bad here. So u1 is equal to, that would be, the 2 would cancel because you get a 1/2 there. So you just get, I believe, just e to the 2x. E to the 2x for that one. And u2 then would be equal to, that'd be, we have negative 4. You get 1/2 because there's going to be a negative 4 down there. Makes the pot, you get the positive half. 1/2 e to the negative 4x. Like that. So then, so I can go for a whole thing here then. So y is equal to c1, whatever those were, e to the negative 9x plus c2, e to the negative 3x, plus now the particular solution. Basically, it's the same thing here again, right? Except that, except you just have, the u's here now instead. So now it's e to the 2x, e to the negative 9x, okay, plus 1/2 e to the negative 4x, e to the 2x. Like this. And then you can clean this up here a little bit. So c sub 1, e to the negative 9x, plus c sub 2, e to the negative 3x. And then that would be e to the negative 7x. Oh, wait a minute. Let's see. Plus 1/2 e to the 2x, or e to the negative 2x. Is that what that seems strange. Wait a minute. Look here. So I guess you end up with this here then, like that. Okay, let me check here. See if I differ anywhere from my notes here, Nat.
e to the negative 3x at the end, right?
Should it be? Oh, yes, yes. Thank you. Thanks. I don't know where the 2x came from. Oh, that was a u. I looked at the wrong thing there. Yeah, e to the negative 3x. My bad. Okay, that seems better. Okay, then we get both negative 7x's there. And then you can actually put those together. Thank you. So y equals c1 e to the negative 9x plus c2 e to negative 3x plus, and then that'd be 3 halves e to negative 7x. Yeah. Yeah, I had that wrong right here. Thank you. I was going crazy. I couldn't figure out what was, it didn't look right. But, okay. So there's the, well, there's the whole thing of it. Okay. Now, the other way you could have done this too, we did variation parameters. You could also have done also undetermined coefficients you could have done, right? You could have said, you look for yp equals a e to the negative 7x. So you could have done that, right? And then substitute it in here and find the a to make it, that makes it work. So probably much easier for this one. So, okay, so anything on that? Okay. And same thing for the other one back here. You could have done that like for the one before it. The first one I did here, you could have done the same thing, right? Except to get repeated here, right? So you'd have to have like, yeah, since it's repeated, and it's repeated over here. So you'd have to go to this then. Now that's interesting. If you did undetermined coefficients here, y sub p, right, it'd have to look like this then. You might start with like a e to the negative 3x. This is for undetermined coefficients, right? But that won't work because that's going to be part of the homogeneous solution here. Okay, so there's no way it can be like this. Well, even then, if I put an x on it, okay, well, even this isn't going to work here for this one because over here, right, because that's part of it too here on this one. Okay, so this isn't going to work either because this is the solution to the homogeneous, right? So there's no way it could be a solution to the non-homogeneous. So this one you got to do actually here, you got to put an x squared here. You got to go up to this one then. So like that. So yeah, then this one could work here then. And so yeah, so something like this would do it here then. Okay, so anything there? Let's see. Okay. Yeah, so that'd be it there. Okay, on to the next one here then. Let's see.
What also they have, obviously, is
Okay.
Oh,
okay. Got here.
And also the osprey. Again, vertical lift. You don't need to run.
I'm going to skip that one because it's apparently too much of a pain.
Okay.
Now, let's try this one here now.
Okay, so that's what they
Let's say we got
quickly. Well, obviously, when you meet with resistance, there is a risk of
y double prime
and also
plus
how to
y is equal to cotangent of x.
Now, today, Netanyahu says Iran no longer has the ability to embrace.
Let's try this next.
Which is obviously significant. Obviously, Trump had said the program was eliminated last summer, was obliterated last summer, actually. Right. So it's unclear what those terms at this point really mean. However, there are 3 main nuclear sites, and I say so we don't know in terms of where, say, enriched uranium.
Yeah, so trying to figure out the general solution to this one. Now, this one's a little different because you cannot do variation. You cannot do undetermined coefficients here. It doesn't work for this something like this. Right, the undetermined coefficient method, that's like if this is a polynomial or if it's like an e to the x or a sine or cosine. But anything beyond that, it doesn't work. Okay? Because if you try to substitute cotangent, anything like cotangent in here, you get different kinds of derivatives. Right? E to the x has its own derivative. Okay? And polynomials basically make another polynomial when you take a derivative. Okay, so they kind of give themselves back here, and they even sine and cosine, right? We take a derivative, you get sine, you get sine and cosine back. They kind of stay closed up. But anything else like this, the derivative here has nothing to do with, it doesn't cycle through like over here. So undetermined coefficients does not work for something like this. Okay, so, but anyway, first thing here, solve the homogeneous part. So we got to do the characteristic equation. So r squared plus 1 equals 0. So here you get then, basically go through it, you get r equals I. Right, so r equals 1i or r equals negative 1i. You go through, do your quadratic formula, whatever, you get this here. Okay, so then what y is equal to, so what would be the general solution from homogeneous? If you have a pure imaginary, right, that's like this then. Right, like that. Okay, plus the particular solution over here. And now we got to just work on finding this here then. So, so now you find your W. Right, so W here then. Let's see what I'm doing here. Okay, so then this is equal to what? That'd be cosine x and sine x. Okay, like that. And then take derivative. So that would be negative sine x. Derivative here would be cosine x. Okay, so then you get, basically here then this becomes what? It's cosine square x plus sine square x, which is equal to 1. Okay, so the W here is just going to be 1. Okay, so then now u sub 1 prime is equal to, that would be this one up here, negative sine x times the f of x is, that was cotangent x here, over 1, you could say. And u sub 2 prime is equal to, and then that would be, okay, that'd be what you get here then, which I lost my train of thought. So this is, you get cosine x here. Okay, times, and then cotangent x, that's the f of x, and then again over w, which is 1. Okay, so then u1 prime is equal to, so then here this is like cosine over sine. So this one would just be negative cosine, right? Negative cosine x for that one. Okay, then over here, not as nice. This is cosine over sine here. So you get cosine square. Let's see, cosine square over sine. Or let me write it like this maybe. Let's get this here then. Okay, so what becomes of this? Okay, well, I guess I'll write like this for now. This is cosine square x over sine x. Okay, so that would be like what? So cotangent. Well, okay. What you could do here then with this, the cosine square, you can write that as 1 minus sine square. Okay, so you get like 1 minus sine square x over sine x. So this becomes then, that's cosecant x minus sine x, like this. Okay, so anything there so far? Now, for antiderivative here, this one's easy, right? And then for the other one here, I'm going to write a couple down here. For antiderivatives, different trig functions. I'll put these in a box here. But we saw these before. Maybe not in this course, but maybe some other point. I'll just write, I got 4 of them here to write down. That's for secant. And then integral of cosecant x is equal to negative natural log. And I'll put these on a sheet or something when it comes test time. So don't need to memorize these or anything. But you might well put these in a box or something in your notes. So I'll kind of shrink these down here maybe then. Whoops. So then back to what we had before there, right? We got the u sub 1. The u sub 1 was equal to, that would have been negative sine x. Right? That's the antiderivative there. And then u sub 2 is equal to what? That would be cosecant is this one here. And don't need the plus c on here. And then the sign, negative sign, that would be positive cosine. So plus cosine x here, like that. Let's get this here then. Okay, so anything there so far on that? Okay, so then y sub p, we may go for the whole thing here. Maybe I don't want to actually, but y equals what would be c1 cosine x plus c2 sine x plus then the y sub p. That was, there's a negative sine x times cosine x. That's this the y sub 1 here again. Plus, and then this awful thing, negative natural log okay, plus cosine x times sine x. Okay, that's times this one here. And so this is basically it here, but I guess you can simplify it some, because if you distribute the sine x through here, okay, you get like a sine x cosine x. It'll cancel this one over here, right? So if you distribute that sine through here, it'll cancel against this one then. Okay, so then when the dust settles there, okay, y equals c1 cosine x plus c2 sine x. Those cancel, and then minus natural log absolute value of cosecant x plus cotangent x, like that. Okay, so this would be then the general solution here then for it. Oh, times sine x. My bad. Because I had to distribute that sine x here. So that would still be on that one then. Okay, so quite the mess there for it. But that's the general solution to the original second order differential equation there. So, okay, any questions on that one? No, pretty good there. Okay, got one more to go. Good, I can do the next one now if there's no questions in that. Let me check here in the chat real quick. See if any questions. Let's go back here. Okay, so let me switch back here then. I'm skipping that one. I worked the word skip. Okay. Oh yeah, this is basically got one more here to do. So this will probably be the last one tonight. We'll get through this section. So let's try this one here. I think it's, well, anyway, so x squared, y double prime, oops, okay. Or I'm sorry, x to the fifth minus 2x. So let's find the general solution to this here. Now this is a bit messier because you notice the coefficients are not constants here anymore in this one, right? So I'm going to try to find, but it's still a second order linear equation. It's still linear, but it's just not constant coefficients. Okay. It turns out I can actually use variation of parameters. Okay, when you don't have constant coefficients even here. Basically, though, to use variation of parameters, though, you got to get in the correct form. If I go way, way back, well, where was it at? I'm going to start off variation of parameters here tonight. You see, this is the form up here for everything to work. So you have it's a 1 in front of the y double prime. Well, it was. It's a 1 in front of there. Where, yeah, right. So if you look at this here, right, there's a 1 in front there to do this. So you can have functions here, that's okay, of x, but it's got to be a 1 in front. Okay, so then basically I got to get in the right form. So divide through by x squared here. Okay, so we divide through by x squared and everything. Get back here. So if I do that here, so you got to get in this form first. So you got y double prime minus, that'd be 1 over x y prime minus 3 over x squared y is equal to, and then divide through by x squared here, and you get like x cubed minus 2 over x, like that. If you divide it through, that's getting the right form. Right, so you get the correct form. Get into this first. So you have a 1 in front there. Okay. Now we're going to also suppose here on this. We're given the complementary solution. This one here, right, the characteristic equation approach doesn't make much sense because you have to have constant coefficients for the thing with the r in it, right? That only works if there's constant coefficients, okay? But suppose in this one we somehow know already for the homogeneous equation, let's say we're already given the solution. Suppose that this is given here. So we're going to assume here that this is given. Okay, we already didn't see how to find it here, but there's ways you, yeah, but anyway here, suppose in this kind of problem, this is actually given. Okay, so you'll be given the complementary solution here. So now once you have that given, then it's just like before, you go right to the same process again. Okay, so we got W equals, and then you just go through this. Okay, so what, that'd be x cubed here, x to the negative first. Then you take your derivatives. Okay, and then so you just do some exponent rule stuff here. So it would be what, negative, I think you get negative 1x, then minus now the other way, that would be minus 3x, I guess, just doing the exponent properties. So you get negative 4x, okay, for that. So we got that. And then now u sub 1 prime is equal to its negative y sub 2, which is this, times the f of x, which is the x to the fifth minus 2x, all divided by negative 4x. Oh, my bad. I made a mistake. See my mistake, what I did? Yeah, it's got to be in the right form. Okay, so that's the x. I got to use this one here, right? So that's x to the third. I wonder if I did that in my, nope, I didn't do it there. So that's x to the third. I'm going to write that as minus 2x to negative first, because I'm kind of the exponent rule thing here now. Okay, so that's that one. And u sub 2 prime is equal to the y sub 1, which is x cubed, times then x cubed minus 2x to negative first over negative 4x. So then y sub 1 prime is equal to, that would be negative, and then distribute through here, so it'd be negative x squared, just using exponent properties, plus 2x to the negative second over negative 4x. Then u sub 2 prime, distribute through there, that'd be x to the sixth minus 2x squared over negative 4x. So we got that. Okay, so then we've got what? u1 prime is equal to, I can put like terms up there now on the first one. So that'd be x to the negative second over negative 4x. So u1 prime is equal to, that'd be like negative 1/4 x to the negative third, I guess there. Exponent properties. And then on the other one, that would be what? u2 prime is equal to, that'd be, I guess not too much to do there. Break it apart. You get like negative 1/4 x to the fifth plus 1/2 x. Let's get this here then. Okay, made a mistake in my note there. Okay, so then now let's do antiderivatives here. So u sub 1 would be equal to, that'd be negative 1/4. Well, let's see if I get that right. That'd be x negative, I think negative 1/8. Go positive though, would it? I think. Positive 1/8 x to the negative 2. Then u sub 2 would equal, that would be negative 1/24 x to the sixth plus 1/4 x squared. So then finally, we could say y is equal to c sub 1, whatever was, okay, x cubed. I'm kind of reading back up off of this now, plus c sub 2 x to the negative first, plus u sub 1 is the 1/8 x to the negative second times x cubed. Maybe I should simplify it first before I write it all here. I don't know. Plus, and then the other one would be negative 1/24 x to the sixth plus 1/4 x squared times x to the negative first. Like that. Okay, and then basically to simplify it out here, so c sub 1 x cubed plus c sub 2 x negative first, plus that'd be 1/8 x, I think there, plus, and then this would be negative 1/24 x to the fifth, plus, and this is distributing here, 1/4 x. And I already have a 1/4, I already have a 1/8 x there, so I can put those together, I guess. So y equals c sub 1 x cubed plus c sub 2 x negative first, plus, and then this would be an eighth plus a fourth, I think it's 3/8. 3/8 x minus 1/24 x to the fifth. Assuming no mistakes in it. which is questionable, but that should be it there. So, okay, so that'd be general solution then. So that's the general solution to the original problem way back up here. I think I got one screen here, if you can, so the general solution to this one here, right, would be this guy down here then. So there's the whole thing of it on that. So any questions on that one? Okay, and we're going to stop there tonight. And next time, we're going to start next chapter, talk about spring systems, springs and mass, like Hooke's law, and some word problems with springs and stuff. So physics, that's the word I was looking for. I can't remember words anymore, but physics, that's the word. So, okay, so we'll go ahead and stop here for tonight then. So